Hello all, welcome to Master Pharma. Today we are going to discussing about a small topic in organic chemistry, especially nomenclature part. Yeah, that is RS nomenclature. Another name of RS nomenclature is absolute nomenclature. That means general name is exact nomenclature. So there are sequence rule in that. We have to get a clear information about RS configuration. Okay. Right, see, there are some rules in RS nomenclature. We can see one by one. First, the heading is absolute nomenclature. Absolute nomenclature. Yeah, we know what is absolute. General meaning absolute is exact. So we have to get exact nomenclature or absolute nomenclature of the each and every chiral center. So wherever the chiral center is present in a big group, in a big molecule, we have to easily get this configuration. So absolute configuration. So before going to absolute nomenclature, otherwise there is a configuration also. Absolute nomenclature or absolute configuration. So another name of this one is RS configuration. Another name of this one is RS configuration. What is R and what is S? R is equal to rectus and S is equal to sinister. S is equal to sinister. So rectus and sinister, these are Latin words. These are Latin words, which means rectus means right. Rectus means right and sinister means left. In general terminology, so right means clockwise direction here. Clockwise. So automatically left means anti-clockwise direction. Anti-clockwise. Okay. RS, rectus, sinister, clockwise, anti-clockwise, right and left. What is happening in right and left? What is right and what is left? So we know already, we have some information about DL configuration, that is relative configuration. So before going to absolute, there is a relative configuration. Relative configuration. So this relative configuration also called DL configuration, right? DL, capital D and capital L. There were some problems or limitations in DL configuration. To overcome those problems, we have absolute configuration. Okay, if you have any doubts in DL configuration, you can see the previous video. What DL configuration? We already made a video on DL configuration. Okay, so here the concept is absolute configuration, right? We have some rules how to write, how to identify absolute or RS configuration in a given molecule, right? So we can see the rules one by one, and there is another terminology, the rules which is present in absolute configuration is called sequence rules, right? Sequence, also called sequence rules. Sequence rules is rules are in order to one by one. We have to follow one by one, right? Those are called sequence rule. In textbook, there are 4 to 5 sequence rule, but according to IUPAC should not involve, otherwise it is moderately involved in this rule, right? So especially this is very difficult topic compared to remaining other configurations. We have to follow these rules, then only we can find out the given compound, right? We can see the rules one by one. Fine. Yeah. So first thing, how can we find out? Right? So in this rule, we have to find out if the given structure contains chiral center or not. That is first one. For example, this is the compound CH3, CHOH, COOH. This is the given compound. So the question is, find out the RS configuration of the given compound. So we don't know how to write this structure, but the question is, find out RS configuration of the given compound, right? We can check out here carbon atom, this is functional group, carbon number 2 and carbon number 3, automatically this is 1. There are 3 carbon atoms, right? So 1, 2, 3. I just convert the structure into Fisher projection. We have already, there is a video on molecular representations also, you can check it that. Right? In this molecular representations, according to Fisher projection, this is the Fisher structure. More oxygen containing group is top side and more hydrogen containing group is bottom side on the vertical line. Okay, right. Here OH group and here H group. This cross or this center is called chiral center. This center is called chiral center or chiral carbon. Okay, right. So here the chiral center or the chiral carbon, we have to find out. First thing, first rule is find out chiral center. This is the first point. We should find out the chiral center. Then go to the atoms or groups which is directly attaches to the chiral center, right? So here, see here. So this is the center, right? So this center is directly attached to OH, here hydrogen, here carbon, here also carbon, right? So we just concentrate on the directly attached atom, right? So this is group, but we have to concentrate on the direct attached atom, not on entire group. See here oxygen is directly attached, here carbon, here hydrogen. So based on the atomic number and our atomic weight, we have to give the priority. So here based on atomic number or atomic weight. So based on atomic number or atomic weight. Coming to the hydrogen is atomic number 1. Oxygen is 8. Carbon both are common. Which one is having highest atomic number? Oxygen. So this is first priority. Right? Don't concentrate on the entire group, right? You should concentrate on the chiral center which should directly attach it to the atom only, not the entire group, right? So this is 1. Automatically this is 4 because hydrogen is very less atomic number compared to remaining any atom in the periodic table. Here there is a clash between CH, carbon and carbon. Here also carbon, here also carbon. If directly atoms both are same, then going to the next point. The next point is this is the directly attached atom. So this atom directly attaches to how many atoms, and those atoms which one is more atomic number, right? So here this carbon, yeah. For better understanding, I am write the structure like this. Here, this is the carbon, right? Here carbon, which is directly attached to hydrogen. Here also hydrogen. Here also hydrogen, right? Next, here also COOH group. This is so COOH group, we can write C double bond O, here OH. This is the representation, right? So here carbon common, right? So that's why I am cancelling these 2 atoms. Next, this carbon directly attaches to how many atoms and what are those? Here hydrogen, here also hydrogen, here also hydrogen. So 3 hydrogen atoms here. Coming to here oxygen with 1 bond, another bond with oxygen. So 3 bonds, 1 sigma and 2 pi. Here 1 sigma, here 1 sigma, here 1 pi, right? So total 2 sigma, 1 pi. Total 3 atoms which is directly attaches to carbon. This hydrogen is not directly attaches to carbon atom, right? So here 1 oxygen, 3 oxygens, here 3 hydrogens. Which one is having more atomic number compared to hydrogen and oxygen? Obviously oxygen, right? So this is priority number 2. And automatically this is priority number 3. So this is the priority order. First rule is find out chiral center. Second rule is based on the atomic number which is surrounded by the chiral center. Right? This chiral center directly attaches to oxygen, hydrogen, carbon and carbon. So oxygen is more, that's why priority number 1. Hydrogen is less, that's why priority number 2. And carbon, carbon, comma, then go to next 3 atoms. Oxygen, 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 hydrogen, hydrogen, hydrogen. Which set is having highest atomic number? Oxygen side. That's why here priority number 2, priority number 3. So priority finished, right? Then third step, going to the clockwise or anti-clockwise direction, right? So before going to clockwise and anti-clockwise direction, we have to close the fourth priority group wherever it is present, whether it is on horizontal line or vertical line. So here this is horizontal line. So close the fourth priority. Close the fourth priority. Start traveling from 1, 2, 3 route. From 1, you can start your traveling from first position and reach to third position. Don't concentrate on the fourth one. That is the rule. That is the rule, right? So here 1, here 2, here 3. So starting from 1, here 2, here 3. So this is the rule. The rotation is clockwise or anti-clockwise? Obviously anti-clockwise, right? So in first point what we discussed, anti-clockwise means S sinister. So this is called S isomer. This is called S isomer. Still it is not finished. Okay, up to here clear. This is S isomer, right? Then last point is, if the least priority group on the horizontal line, we can change the configuration from one position to another position or one isomer to another isomer. Yeah, search where is least priority group, that is hydrogen, which is on horizontal line, not on vertical line. So on horizontal line there is a least priority. Then another representation. There are 5 types of representations in stereochemistry. So first type is Fischer projection. Then coming to the another type representation, same structure, another type representation. We can check out all these things. For example, same structure. I am going to write the same structure here. CH3 here, CH here, OH here, COOH. Okay. By the way, this is the name of lactic acid. Lactic acid. So there is a flying birds representation if the structure is in the form of flying birds representation. So flying birds representation is, there is a front side bond or front side of the observer or thick bond, right? This is back and this is in plane and this is the in plane. If the representation is like this, you can keep any atom or molecule at any place. So this is called, this center is called chiral center, right? So for example, I am going to write hydrogen here, COOH here, and OH here, then CH3 here. Clear? Right. See, OH, clear, OH, CH3, here CH3, H, here H, COOH, COOH, this is chiral center. This is second type of representation. Fine? Yeah, same, you have to concentrate, identify the chiral center, same rule which is present in Fischer projection. Then coming to the second one, we have to give the priority based on the atomic number. So already we know, right? So oxygen is more priority, that's why number 1. COOH, already we discussed, this is priority number 2. This is priority number 4 and here priority number 3. So priority order finished. Here also you can close the fourth priority and starting traveling from 1 to 3, right? This is fourth one, close it. Okay, so here 1, 2, here 3. So this is also anti-clockwise direction. So it is obviously S isomer. S isomer. Okay, yeah, here also there is a rule. In Fischer projection, on horizontal line there is a least priority group, we have to change the configuration from one to another. Here also, if the least priority group on front side of the observer, we have to change the configuration. Front side means that is on thick line. That is on thick line is called front side of the observer. We have 3 bonds in flying birds representation. First one is thick line, second one is broken line, and third one is in plane. Okay, this is thick line and this is broken line and this is in plane, and this is wavy line. Wavy line is not at all considered. That's why we have three bonds in flying birds representation. This is front side of the observer, this is back side of the observer, this is in plane. So front side and back side are out of plane. These two are out of plane. These two are out of plane. Fine. So here, if the least priority group on front side of the observer, we have to change the configuration from one to another. Okay. So here, fourth one, there is a least priority group, hydrogen. That's why we have to change the configuration S to R, or isomer. Or isomer. This is about RS configuration. Who proposed those rules, right? We have some rules, sequence rules, right? So the scientist name is, scientist name is SIP. Full form is Con, first scientist name. Second scientist name is Ingold. And third person name is Prelog. Third person name is. These three scientists proposed those rules, sequence rules, right? So according to this, we have to find out the RS configuration of the given compound. So that's why another name of RS configuration is called SIP rules or SIP configuration. So here there are 4 to 5 names: absolute nomenclature, or exact nomenclature, or RS configuration, or sequence rules containing configuration, or SIP rule. Okay. SIP means Con, Ingold, Prelog. These are the scientists. We can check out 2 to 3 examples. Then we can finish the topic, right? See. In cyclic compounds also, we can find out. These are the previous questions, previous topic questions. Okay, right. So we can check it one by one, right? First case. So how many chiral centers here? Here we have one. Here carbon atom, carbon containing C double bond O group, and OH here carbon, single carbon only, right? So automatically one is front side of the observer, so there is a hidden hydrogen, that is back side of the observer, right? This is the correct representation. But in examination they will not give the back side representation. There is a front side, automatically there is a back side present. So here also there is a back side hydrogen. We know, right? This is the structure of benzene. This is the formula C6H6. So obviously we know here there is a hydrogen. Every time we should not represent this. Here there is a hydrogen. We already know. Here also there is a carbon, means there are 2 hydrogen atoms, right? See the first example. So first rule is we have to find out the chiral center. Here chiral center. So give the priority. Here carbon directly attaches to hydrogen. Here OH. Here carbon and oxygen. Here carbon. So hydrogen directly attached atom. We know hydrogen is obviously least priority group. So here 4. Directly attached atom oxygen. Directly attached atom carbon. Here also carbon. So oxygen is more compared to carbon and carbon. So this is priority number 1. And coming to this one, carbon and carbon. This carbon attached to hydrogen, hydrogen, here one hydrogen, here also one hydrogen, here another carbon. Here carbon directly attaches to oxygen, oxygen and carbon. So hydrogen, hydrogen, here oxygen, oxygen. Which one is more priority? Oxygen, obviously. So this is priority number 2, here priority number 3. Close the fourth priority. 1, 2 and 3. So this is clockwise direction. Clockwise direction means R isomer. R isomer. What is the last rule? If there is a least priority group on front side of the observer, we have to change the configuration, right? Here least priority group hydrogen, that is back side, so no problem. The final nomenclature is R isomer only, right? Coming to the second one, here also same. Here carbon, CH3, here carbon containing bromine, carbon, carbon. So this is also chiral center. Fine. So carbon, here carbon, carbon, hydrogen. Hydrogen is more least priority, that's a fourth priority, right? Here carbon, here also carbon, here also carbon with bromine, right? Here carbon, hydrogen, here hydrogen. Here carbon with bromine, that's why this is priority number 2. Here carbon, hydrogen, hydrogen, carbon, here hydrogen, hydrogen, hydrogen. Which one is more priority? Top side. This is 3. Okay, so 1, this is 1, sorry. Yeah, so here 4, right? Coming to the carbon, here also carbon, here also carbon. So if 3 are common, then move to the another atom, right? So here carbon attached to bromine, carbon attached to 3 hydrogens, carbon attached to 2 hydrogens, 1 carbon. Here 1 hydrogen, 1 bromine and 1 carbon. So bromine, obviously this is priority number 1. Here carbon, hydrogen, hydrogen, carbon, priority number 2. Here carbon, 3 hydrogen atoms, priority number 3. Same, close the fourth priority closed. 1, 2, 3, starts from 1, 2, 3. Clockwise direction, so it is R isomer. Yeah. Next, last point is, if the least priority, we can move to the, change to the configuration. It is front side of the observer, but here back side of the observer, so no need to change the configuration. Final configuration is R isomerism, right? Coming to next one, here, this is chiral center. Here oxygen, carbon, carbon, hydrogen. So here priority number 1, here priority number 2. Yeah, carbon attaches to hydrogen, hydrogen, oxygen. Here carbon attaches to oxygen, oxygen, hydrogen. Which one is more? Oxygen, oxygen set is more. Here 2 and 3. Close the fourth priority. So 1, 2, 3. Anti-clockwise. So it is yes configuration. Right? Least priority group on front side of the observer, we can change. So least priority group, here 4, least priority group. So finally this is R isomer. These are the representation. There are number of examples, right? There is a toughest example which is appeared in the examination. See it carefully. We can discuss the topic. Yeah, I'm going to once again write the compound there. Okay, so this is called Nor-Bornean representations. These are called Nor-Bornean representations. So simply we can convert this compound into general structure, that is you can convert the structure into this molecule. Okay, so here carbon number 1, here 2, 3, 4, 5, 6, here 7. So here also 1, 2, 3, 4, 5, 6, and here this is 7. Okay, this is bicyclic compound. Okay, bicyclic compound, there are 2 backbone carbons or backbone atoms. Okay, so we have to identify the given structure containing whether chiral center or not. Right, so here this is carbon, One is front side of the observer, automatically hydrogen is back side of the observer. Here hydrogen is there. Right, so one is hydroxyl group, another one is hydrogen group. Here carbon with C double bond O, here carbon with carbon. So obviously this is chiral center. How can we find out the configuration, right? Yeah, chiral center directly attaches to carbon, carbon, oxygen, hydrogen. This is first priority, this is fourth priority. So there is a class between 2 and 3. Here carbon directly attaches to oxygen, here carbon, hydrogen, hydrogen, carbon. The set is here carbon, oxygen, oxygen, here hydrogen, here carbon, right? So for example, I am going to write C double bond O here and carbon, here C, here also carbon, but here hydrogen and hydrogen. So this set, carbon, hydrogen, hydrogen, carbon, here carbon, oxygen, oxygen, carbon. Which one is? This is first priority, right? Compared to these two. So automatically first priority finished, fourth one finished. This is priority number 2 and this is priority number 3. Start the traveling. 1, 2, 3. Where is 1? Here 1, 2, 3. This is clockwise direction. So clockwise direction, that is why it is called R isomer. But what is last rule? If the least priority group front side of the observer, is there any least priority group on front side? No. No least priority group. That's why R configuration is final or R isomer is final. These are different types of representations present in the RS configuration. If you have any doubts regarding this, you can come to the inbox. Thank you all of you. Thank you so much.